Really?
So, good evening, everyone. We welcome you all to the AIOS International Ophthalmic Conclave 2024 with the curated best of knowledge from all across the world by the All India Ophthalmological Society. I'm Dr. Rituja Thomas Grover, and I will be your host for this session on AI in ophthalmology, a paradigm change. And I invite the moderator of the session, Dr. Rajiv Raman, a prominent name in VR as well as research all across India. He's from Chennai in India. And I invite him to introduce the chairperson and the faculty and to initiate the session. Over to you, Dr. Rajiv.
Thanks, Rituja. So today this session is mainly on AI in ophthalmology, a paradigm change. We see, though it started with diabetes, diabetic retinopathy, but we have now AI in nearly every aspect of ophthalmology, and ophthalmology lends itself to, because of imaging, because everything can be imaged, it lends itself to AI very well. And we'll have some of our esteemed speakers who will be going through basics of AI. Today we have large language models, how we use it, the predictive utility of deep learning, and then finally we will have how we can translate these into clinical practice. We have with us our esteemed chairperson, Dr. Kim Ramaswamy. I think he's one of the best person. I would say the only one who has used AI for diabetic retinopathy so extensively globally. Nobody can match the numbers, and he knows how the intricacies, the good thing, why it is a double-edged sword, what is wrong with AI. He understands everything. Welcome, sir, for the meeting. Like few words from you, and then we start with the first talk by Dr. Les on understanding the concepts of deep learning for medical professionals. Dr. Kim, please.
Thank you, Rajiv. This is, I think, a wonderful initiative. Today, the buzzword is AI. That's the only thing that everybody is talking about. Any specialty, any field. It doesn't matter whether it's healthcare or any industry. People are talking about AI, and then I don't think we can do away with AI. But everybody thinks AI is just one component. But there's, as Rajiv mentioned, there are so many things that are happening. It started with the low-hanging fruit of diabetic retinopathy, but today, with as he mentioned, there's a lot of things that is happening with the MedPalm 2 and few other things that are coming in. I think it's going to change the whole scenario how we practice. And if we don't, as ophthalmologists or as even people in the healthcare, do not acclimatize to the use of AI, I think we'll be left behind. So it's very important that every one of us understand, whether we use it or not, understand what's coming, how AI can impact our practice is very important to understand because it has its own benefits and also the other side effects of it. But I'm sure there's a lot of positive things that we see that can impact or improve how we practice medicine. I think this will change. So without much this thing, I would hand over to Dr. Rajiv for further discussion. We have a wonderful set of speakers today who are going to share what AI is all about. I think there's a lot of learning that can happen today, and I really look forward to this whole symposium. Thank you, Rajiv.
Thank you. Thank you, sir. So I would like to request our first speaker, Dr. Les, who would be talking to us on understanding the concepts of deep learning for medical professionals.
All right, thank you. I'm privileged to be here. Thank you, Dr. Kim. Thank you, Dr. Vipin. Thank you, Dr. Rajiv, for the introductions. I'm coming from Thomas Jefferson University in Philadelphia. Let me share the screen. Oh boy, yeah, where are we? Let's see. Have it prepared. Okay. Let's go back, share the screen. All right, here we go. Now I have to break it. All right, how do we maneuver? All right, so welcome. Thank you for the invitation. It's a privilege to be here. We have a long-standing collaboration with LV Prasad in India. We have Jefferson has an India center with ongoing exchanges with students and faculty, and our global provost, Dr. Richard Derman, is soon going to be in India. So I'm going to talk about deep learning for medical professionals. As Dr. Kim mentioned, it has started, but it has evolved into so many fields because of the image processing and how Dr. Rajiv mentioned it lends perfectly for applications. So right. So we break about our digital health and AI at Thomas Jefferson University. So I say that Jefferson, we don't raise the bar in education excellence, we are the bar. So within the medical professions, within the Doctor of Medicine program, we have the digital health track that trains medical doctors and the students in ways that artificial intelligence could be used to promote health and well-being. And it's also being extended to the public health, where we have the first, Jefferson has the first college of public health in the United States. So we have the digital health track where the students embrace a number of courses. I teach data mining and machine learning there. So it's designed to help future physicians and medical professionals to improve clinical care and patient outcomes through the use of AI, obviously. And but we collaborate with a variety of stakeholders, including healthcare professionals, as well as patients, as well as right now Thomas Jefferson University acquired non-profit insurance. So we are there as well. Let me just move this up. So the students opt for some of the courses, but what I bring a slightly different angle. Basically you have to practice what you preach. So the students are involved in projects with healthcare providers, hospitals. With the new acquisition of the Lehigh Valley, we are going to have 60 hospitals that we operate uh, um, in. So deep learning is the basically machine learning based on artificial neural networks. So artificial neural networks, so you have multiple networks there. They are little processing nodes that mimic part of our human brain. And the particular deep learning is based on the feed-forward network. So all the nodes, the input, the hidden layer, and the output only connect to the neurons going forward. So we started with the engineering of machines with that mimic cognitive functions way back. Then we have the machine learning. Then where the computer guides robotics and relies on patterns to recognize them and make recommendations. And finally went into mimicking the human brain part of it with the artificial neural networks, and we have machine learning based on that. So there are multiple applications where deep learning has been providing breakthrough results, especially in image classification. We have very strong radiology program. We have the Sydney Kimmel Cancer Center nationally recognized as one of the best. But it goes pretty much everywhere as long as we have the training set and then the set that we are going to predict the outcomes. We are going to learn, the network is going to learn and guide us. It basically, we present the patterns over and over again, and the weights between the neurons are being established, and then they are either going to be suppressed or strengthened, eventually leading. It's a self-generating neural network, so the number of hidden neurons in the hidden layer is automatically generated by the deep learning, and then we go into the output. Obviously, you have to consult the physician to make decisions. So what I do in my courses at the PhD level, doctoral level, and actually in all the other courses as well, I incorporate concepts of machine learning. So the course is a doctoral level course on machine learning, and the MDs and the medical professionals and biomedical students go in it. What do? We collaborate. We seek permission to use some of the data, and I'm going to show you some of the projects we did with LV Prasad. So let's it's going for by years, and then that's the basis of my talk, and all of it has data, because we live by the concept that in God we trust. Everybody else brings data, especially in medical professions. So in 2023, 24 going on right now, we have two MD and the Master of Public Health students working with LV Prasad Institute right now. And the students did an outstanding job, just outstanding job. And it's a collaboration with Dr. Vipin and Fatima and Anza are currently in Liberia with the support of LV Prasad, and under the guidance of Dr. Niranjan, also ophthalmologist exploring conditions and observing eye surgeries in Liberia, that a lot of them are being performed by our Indian collaborators at LV Prasad. So additionally, they working with the local health communication experts, because remember, it's medical professions as well as public health in creating patient and education material. So I'm very proud of that collaboration, and Dr. Vipin is the leader there, but Dr. Niranjan is supervising them. So they are outstanding fourth year medical students, and starting breaking that before graduating, breaking it and getting the master's in public health as well. So that's just one of our collaborations. The other one I'm very proud of, and I supervise a doctoral dissertation in deep learning for eye disease classification. We had nearly 1 million patients coming from India, and it was a data-driven approach. It was the machine learning with the feed-forward neural network and other AI techniques for eye disease classification. But what we did and we still do, we use a lot of data that relates to social demographics and the social discriminants of health. And we use the demographic and weather factors. And that was a fantastic collaboration. The student was Amna Alalawi and LV Prasad with Dr. Vipin, and there was one more collaborator there, yours truly, and Parth Lalakia, who is our global officer that collaborates with India centers. So that was fantastic. She defended the dissertation. Another one, we are part of the global consortium that we have 42 different countries on 5 continents. And are we right on time?
Yeah, you can please continue. Please continue.
Right. So another project was we worked with lots of collaborators and then companies, and they are global. So one of them was the detection of viruses on the surface in hospitals, and also the classification of the viruses, bacteria, and contaminants. And it was the European startup company founded in 2019 in Finland. And what we used deep learning and machine learning, and basically utilize sensors, because even COVID and all the viruses and bacteria and contaminants, they leave a fingerprint on the hospital bed, on the you can even use it in cafeterias, but it's invisible to human eye. When you put the ultraviolet light on it, you will detect the bacteria, and we can classify them. So again, a powerful application of deep learning algorithms going back to 2021, 22. And then one of my students, he is now the CEO of the aluminum shapes. He provided us with the project to set up COVID-19 drive-through testing centers. And again, it was lots of data. Remember, in God we trust, everybody else brings data. So it was geolocation, statistics, and also the social determinants of health to place the drive-through testing centers, and with the special sensors there. And again, I'm very proud, and Jefferson is very proud of this. This is our double alumnus Solomon Rosenthal, who provided the project for us. Another one, again, medically related, data was coming from India as well as multiple centers in the United States. The distinguished daughter of Pennsylvania startup Physica, and it was all about collecting data and designing guidance for and engaging patients suffering with dementia. And one of 5 of the components of the projects was based in India, and we utilized the data and the software properly, the software there. So again, another project associated with this was to design a dementia clinic in Finland, where all of it, even the environment, was based on a simulation. And again, we utilize a lot of data, including the social demographics and geolocation, to have a space, virtual space, where the patients don't recognize where they are, but yet walking and recalling the memories of fishing or hunting or talking to the grandkids. So it's a booming dementia is a serious disease. So it's yet another twist, not just the eye centers. Another one we doing a lot of AI work in Johannesburg, at the University of Johannesburg in South Africa, utilizing this. And the Vice Chancellor is our Dr. Marwala is our very good friend. He now has become the United Nations Under Secretary General, and he pushes the initiatives in India and in Africa. So we have a lot of collaborations there starting right now. So what we did there, we guided the first responders on the scene. It's an enormous health system, including the ophthalmology as well. So here's the project I mentioned in Finland with another dementia neurological clinic that basically adjusts to patients' needs. As we speak, I have a few students right now working on yet another project in Finland, and today they have the half-day show. So here's our project, the huge team. On the right-hand side, you have the Thomas Jefferson University team. On the left-hand side, you have a mixed team of Finnish, Portuguese, and Indian students participating in this project. So it was all empathy-based. So it was the digital cloud platform that physicians and clinics could access, and patients could update their daily routines and monitor that. Again, lots of data, deep feed-forward neural network processing and suggesting the best environment and actions. Yet another one, I don't know whether we have time to show it. It's a little video clip where one of my students was the CEO of the new product development at Under Armour, so it's a global clothing company. However, we were charged to develop outfits for college students. However, they changed it to medical professionals, utilizing the data and the support for the back. And they said that medical professionals are different types of athletes. So that's what we did there. I don't know whether it would play or not. To make all athletes better. So the students twisted it. Let's address medical professionals. They are different type of athletes. Another one yet where deep learning was utilized was for the U.S. Department of Defense, where we entered the competition. It was just for professionals, the students who usually don't participate. I entered 4 teams, and one of them won the whole competition for all the professionals. You have to, you see the 6 girls there. They won the top prize, and again, it was enormous effort to expose them to the algorithm and training and the process, but they also used empathy. One of the students, her brother was a Navy SEAL, so they invited Navy SEALs for a beer and a pizza, and just use the empathy. Where does it hurt? And then broke the textile, the pants or the outfit into pieces, and incorporated new fibers into that would strengthen the health and performance of soldiers. Another one, well before COVID, we had again entered the National Textile Student Design Challenge, and they earned the 2nd place for the mask. Lots of data, but we took it as a stigma. in a lot of Asian countries, they use masks well before COVID, but it was again data and nanoparticles and for antimicrobial features. Last but not least, we actually participated in design of the trauma center at the Helsinki University Hospital. It's the top 10 medical center in Europe. So again, in God we trust. All others bring data, especially in healthcare, and I'm privileged to be here. Here's one of my textbooks that utilizes applications of artificial neural networks in the healthcare. Thank you so much. I hope I didn't exceed the time.
Thank you. Thank you, Professor Les. It was really a great talk and amazing to see the applications, variety of things, how you have used. We can probably have the comments at the end, or if you, Vipin, what you want to have it now, we can have. Anand, you want to add anything? Any comments?
I was just wondering whether we do it in the end or both are okay with me.
We can do it now itself. If somebody wants to go, types.
Yeah, just the question around data and collection of data, especially as you work across geographies. Some insights in how the university has tackled the problem with respect to collection of data and some of the processes that you use in doing that.
Yeah, that's a very sensitive issue. There's lots of implications and ethical problems, and how do you obtain the data, how you remove the names, and so on. So it's a collaboration. We don't sort of go after the data. It's a collaboration with specific medical centers, and that was the case for India, where we obtained the data of nearly 1 million patients, in addition to the daily weather forecast and social demographics, and then you can focus it on younger people, the middle age, and then the elderly. But you can also focus on it on specific areas like zip codes. So in Philadelphia, in one place, the Museum of Art, it borders 2 zip codes. So if you go on the right and left, the life expectancy drops by 25 years. 25 years. So it's not your medical data, it's the zip code that is going to tell you how long you are going to live. So, but I appreciate the question. We are very sensitive about it, and it's a collaboration, and only the data we could use and recommended by our Jefferson India Center, or the other centers. We have all Ireland Center, all Ireland. So we have the Northern Ireland and Republic of Ireland. We have the Italy Center, where one of our professors is the former mayor of the city of Rome in Italy. He's the famous surgeon. So again, in medical professions. But yes, absolutely, the same thing with Italy. They have very strict restrictions in terms of accessing the data. And in South Africa, the same thing. It's just an uphill battle, but it's only with the permission and guidance from our partners.
No, thank you, Dr. Les, for a wonderful talk. The only thing I just wanted to add is the importance of collaboration and also working with experts who can give you a different perspective. So I really enjoyed the project of the weather with Amna and Dr. Les guiding us. So I think we should strongly encourage medical professionals to also, you don't have to be a complete expert in deep learning, but understand the applications and the principles. And it's fantastic to see that the applications of deep learning is beyond just clinical data, and a lot of other tools, and also things like, I'm excited to look at a redefined mask. So I think data, what you said is absolutely right. In God we trust. Everybody else brings data, but we should focus on looking at opportunities, if I may say, right? And also work with leaders in the field to basically together form a team to look at the wonderful questions to us. So anyways, thank you, Dr. Les. Thank you.
Thank you so much. It was a
Thank you.
privilege.
Thank you, Dr. Les. It was really a great talk. And now we move to the next talk, and we have with us Professor Daniel Ting. I think none of them who have been working on AI would not know him. I knew him from the first publication on the multi-ethnic population diabetic retinopathy data. I think from there he has gone a long way, really contributed. And today our understanding on AI in ophthalmology is much because of the work done by Dr. Daniel Ting. Not only the work related to algorithms, but even setting the guidelines, how to write a publication which is related to AI in healthcare in ophthalmology. Welcome, Dr. Daniel. And I would like him to talk on a very important topic. He has been working for last couple of years on large language models in ophthalmology. And I think I heard this talk in APVRS, and I thought that this is a talk which AIOS audience should definitely listen. Dr. Daniel, please.
Thanks, Rajiv. Thanks very much for the kind and flattering introduction. So let me just share my screen here. Rajiv has been a very, very, good friend from day one when I started doing deep learning. And hopefully I could actually just share this with, the audience here. So, I'm going to spend the next 10 to 15 minutes to talk about generative AI in ophthalmology. And of course, large language model is being one of them. So this is some of my financial disclosure. So I think ChatGPT at OpenAI is no foreign to anyone here and no foreign to anyone, around the world. Sam Altman, of course, have a very interesting and chaotic 2 weeks and, being ousted as the OpenAI CEO and then re-invited back, after just a few days. So, this is one of the chart that I've got from a public domain. And if you talk about ChatGPT, this is probably one of the most powerful AI engine that mankind has ever seen, to date, right? So if you look at Spotify, Instagram, Uber, or even like TikTok, right? It takes like, all these companies more than 9 months to hit 100 million users. And you look at ChatGPT, it only took 2 months to hit 100 million users worldwide. And right now, I think we are currently talking about more than 1 billion users worldwide as we speak. So what is a really large language model is something that Google actually has introduced back in 2017 using a transformer architecture. So it's also a form of deep learning that's actually trained on the massive text data sets. So from my previous career, looking at pixel-based, image-based, the text. So now our large language model is mainly focusing on text-based, the tasks. So basically, the sheer scale of data and parameters allows the large language models to understand and generate human-like text, and making them a very, very, powerful tool to do a few things. And as you can see from the chart, they can actually help with, the curriculum development. They can teach, they can personalize the study plans, they can assess and evaluate. They can also help us with the scientific writings and proofreading as well. And of course, the medical research and also literature review. So this is some of the major large language model engines, right? GPT-4, Gemini, that is the main and major competitor from Google. So, and of course, the open source ones is Llama 2, Falcon. There's more and more open source, the network that we are actually currently looking at. This is the evolution of GPT. If you look at 1, 2, and 3, and the data sets, the model architecture, the parameters have actually increased tremendously over the different versions of the GPT. And the performance-wise, as you can tell, GPT-3 has actually superseded the previous few versions by a lot, in terms of performance. And for Gemini, which is introduced by the Google, the Ultra is the biggest model right now, and Gemini Pro is the intermediate, and the Nano is a small, the small and the most efficient model. And if you look at the Gemini Ultra versus the GPT 4.0, they actually comparable, and in fact, they claim that they slightly outperform GPT 4.0 in the text, math, coding, and also the image, video, and audio. So basically, essentially all the different tasks. And one techniques that you need to know about all these large language models is what we call reinforcement learning with human feedback. So if you can look at all the different large language models is built using both the low quality and high quality data. They're pre-trained on them. And then using the human feedback, they could actually fine-tune the data and make the data and the performance better. So basically, the prompts engineering is a very, very essential and crucial steps when we actually talk about large language models. So prompt engineering, we have to optimize them because the large language model, when it was first introduced, they actually struggle with the task that requires the knowledge of the data, the system, and the processes. So essentially, prompt engineering is also what we call it as the state of art of asking a questions, right? So like being a doctor's clinician, you sometimes actually need to know how to actually ask the right questions to retrieve the right information from your patients. So this is just an analogy how you should actually be using a large language models to ask the right questions so that you can actually get the right information. There's one very popular technique called the RAG, so Retrieval Augmented Generation. It is an AI framework for retrieving facts from an external knowledge base to large language models. So using these techniques, you can now create your database and direct your AI to go into the specified source, the origin, to actually retrieve the information. So people, especially in the healthcare settings, we know ChatGPT 4.0, we know Gemini Ultra, they're all trained in the commercial base, the information. So for healthcare related stuff, we actually find that using RAG actually significantly improve the performance for healthcare related applications. So we published this paper in Nature Medicine just a few months back, and right now, I mean, it's been cited for more than 200,000 times, 200 times now already. And essentially, we highlighted the opportunities and challenges in using large language model in medicine. So I mean, if you look at the three main category of the function, they are very good in organizing and summarizing the medical information, proofreading, and generate the preliminary draft of the scientific content. And of course, the highest hanging fruit will be using them to make and build clinical decision support tool as well. So I mean, this is just one of the papers that I pull out from the public domain where it shows that these are the different large language model engines used to actually pass the US MLE exams. So as you can tell, MedPalm 2, which is introduced by Google, actually has outperformed the rest. Together with the AAO AI Task Force, we have actually published this paper called the Gen AI, the use cases in ophthalmology. And of course, with the worldwide AI experts, we also published another one in Lancet Digital Health, looking at large language models, impact in ophthalmology. I've actually got, two things to show here. One is to see how we can actually combine the deepfake and ChatGPT generated content to actually provide patients counseling.
Hello, I'm Dr. Daniel, your retina consultant. Today,
so I actually fed some of the
retinopathy,
real face photos of mine into the code
and its
using a deepfake as a
diabetic
backend
retinopathy
technology
is caused
to
by
build
high
this.
blood sugar levels damaging the retina's blood vessels.
Okay, so this is just one, and the second one is to actually explain what
I'm
the
Dr.
retinal
Daniel,
detachment is.
a dedicated retina surgeon. Today, I want to quickly share with you how we address a serious eye condition called retina detachment. In this condition, the retina, which is crucial for vision, separates from the back of the eye.
So essentially, when we see patients in a clinic, our chair time is really short, right? So 40 patients in 4 or 3.5 hours clinic, it's just not enough time to actually talk to every single patient in a very slow and a very layman languages. Especially if the non-English speaking, in Singapore, we see like patients speak in Chinese, Hokkiens, and different dialects and things. I'm sure in India, there's the same thing. So how do you actually leverage on this very powerful AI tool to actually bring the medical knowledge closer to your patients so that they really are understanding the conditions, the procedures, the surgeries that they're going to go for? I think this is going to really bring medical care to the next level.
I'm Dr. Hello.
So this is one of the things I wanted to show. Like if you are sitting in the clinic wanting to explain the cataract in Japanese, and so happen that your Japanese translator is not around.
こんにちは、ジョミ
Okay,
です。
so only
目
for
の
those of
健
you who
康に
understand
関する
Japanese.
専門的なガイダンスを提供するように設計されたスーパー AI
And as you can tell, if you're very sick of your own face, you want to put a K-pop face, like you know, or like Hollywood pop or J-pop face, you can actually choose the face and the voice that you like as well. So basically, generative AI in ophthalmology, that apart from text, the image is also another type that the data modality that you can generate. So basically, we also published this paper. I mean, this is one of the Yen Goodfellow papers published back in 2014 called GAN, Generative Adversarial Network, where you can actually, you know, generate the different pictures based on someone's age. So you can use a baseline photo of, say, 20-year-old, you know, the gentleman, and then you can use GAN to actually predict how this person is going to look like when he hits like 80 years old. And this is some of the work that we published previously. And I always like to ask these questions to ask the retina, the world-renowned retina specialists, to guess which retina image is fake, right? We spend all our lifetime looking at retina photos. And essentially, I haven't seen one person who get these two images right. So essentially, the one label in the asterisk is generated by the synthetic AI machine. So as you can tell, it's actually very real, and it's really, really hard to actually see which ones is real versus fake. And one of the highlight that I actually been to CS. I just came back from Vegas, and then Fei Li was actually predicting like Gaussian splatting for 3D image reconstruction is going to make a breakthrough, right? Fei Li is considered the godmother of AI, based from Stanford, and in the panel discussion that both she and Andrew Ng has actually described, and of course another one is called the vision language model. How do you feed the image of a retina imaging, a radiology imaging, or say like a ERG, the imaging, and get the AI to report the scan. So this is what the vision language model can do. And of course, future of eye care, I think if you could combine both the imaging based, the text based, and multi-model, the data, the input to do triaging, diagnostic and treatment and prognostication, I think this is one of the, the holistic care that I think I hope AI can actually help the clinician to do. And of course, the challenges would be AI, data security, the hallucination and confabulation is one of the safety issues that we are concerned about large language models, AI ethics and biases. This is one of the other one, right? And then of course, the training data sets and intellectual property. So New York Times, is suing OpenAI. This is a very world famous news. Who owns the intellectual property when you actually build large language models? So this is one of the things that I just wanted to end. The tech leaders, the deep learning godfathers, Jeff Hinton, Yann LeCun, and of course, Yoshua Bengio, they all have divided thoughts in terms of how we should regulate large language model and whether we should pause it before we figure out what this large language model can do, or we should actually continue to do it while putting a lot of the safety framework around the technology. This is, the divided thoughts, in terms of building AI towards the utopia versus the dystopic environment. So with this, I would like to thank the committee for the kind invitation to speak again. Thank you.
Thank you. Thank you, Dr. Daniel. Any comments, any questions from the panelists? Or any of the speakers, they can ask any question.
Thank you so much.
Yeah, please continue. Continue, Anand. Then I'll take.
Go ahead and I'll then come in after that.
Yeah, I just wanted to check that what you feel that these large language models which are currently available, and we have also tried using ChatGPT 4, and it could detect risk factors for diabetic retinopathy, like we fed in our population-based data, very accurately predicted whether they will develop retinopathy or not. Do you feel, is it the right time that we should have a ophthalmology specific foundation model?
Yeah, so I think Pierce has actually published a paper in Nature called the Red Found model. So basically, they actually look at fundus-based foundation model, OCT foundation-based model. I think, in the paper itself, they shows that, compared to the ImageNet pre-trained CNN, they actually show a superior, performance using the deep contrastive learning technology. I think this is it whole promises. in my mind. But without further testing and validation in across the different population, we still don't know. So in my mind, it holds promises, but I think it needs a further validation on that. Yeah.
Yeah, Anand.
Thank you so much, Dr. Teng. Always wonderful hearing you speak, and it's amazing to see the progress that's being made. A quick question, or continuing on the foundational model, is: are we seeing the fact that there are certain initial applications where we are seeing textual, a lot of what metadata could contribute to traditional CNN models that are usually image-based? Are you starting to see a lot more importance coming out of the quality and the weightage that's being given to metadata now, especially when you combine LLMs along with CNNs in these foundational models?
Yeah, I think the metadata itself is one. I think the report findings is another one, right? I mean, when we're actually doing the pixel-based and image-based learning, I try my very best not to actually touch the text because it's so chaotic and everyone is saying like it's so dirty. And now, you know, all these like the so-called dirty data has become the gold mines. And, you know, people in radiology part, the pathology part, now, you know, this is their game. Ophthalmology, we used to come from pixel-based, and a lot of the things that we are doing is a lot of classifications and binary categorical variables is less, you know, less so in terms of having a free text. So I mean, the only few free text tasks that I can think of is like, you know, ERG reporting, FA report findings, and ICG reportings. But you know, I mean, for the image, the fundus-based, OCT-based like gradings and things, we usually have a categorical or continuous variables. So I mean, those are the few things that I feel like ophthalmology has not, you know, look so, you know, sexy as compared to the radiology and pathology space. But you know, I mean, a lot of the things that we are doing now, you know, VR surgeries, for instance, right? People are actually commenting on the surgical videos and things. And these are some of the multi-modals things that I think generative AI could actually play a very huge role that the previous pixel-based or the image-based deep learning cannot actually do. Yeah.
Great point.
Thank you. Thank you. I think we have Dr. Balraman Ravindran, Professor Ravindran from IIT joined us now. And I think before we move to the next talk, it's important to understand some basics of AI. So Professor Ravindran heads the computer science department at Indian Institute of Technology, Madras. I think I would say father of AI in India.
No.
I would not be. So he was recently with the names which you told, he was sharing stage with them. The father. That's the reason I immediately said he's also father of AI in India. I would request Professor Ravindran to give his thoughts about AI. He will talk something different. He will talk about really whether AI, what is good, what is bad about it. Professor Ravindran.
Thank you, Dr. Rajaraman, and thank you for embarrassing me knowing. I apologize for joining the call late, and I also believe a little bit of what I'm going to say has already been anticipated by Dr. Ting. So I'm not sure whether our orders of our talk should have been flipped, because I'm going to give something that sets the stage for what are LLMs and how do they operate and what are the pitfalls of using LLMs. So let me quickly so the topic that was given to me was understanding LLMs. I hope people can see my slides. I just wanted to correct one more thing, that Rajan, I'm the head of data science and AI, not computer science. But
yeah.
So again, a lot of excitement nowadays, right, with the LLMs. In fact, I was looking up use of LLMs in ophthalmology, and then I found this survey article that said at least 32 articles have looked at using things like ChatGPT and Bard in ophthalmology just in the first 6 months of 2022. Right? So there's a lot of excitement in this space, and of course, people also have a lot of fear and what's going to happen, and so on and so forth. My take on the use of LLMs is that regardless of what domain that you're applying them to, they're going to give you a huge productivity boost. more than being replacing humans or anything. There's going to be significant productivity boost for how people go about solving problems. So here is my 101 introduction to what LLMs are. Right? So GPT stands for generative pre-trained transformer and all that, but really doesn't make much of a sense to us. The way to think about these the GPT and other things is that they are what are called as language models. Right. So I'll give you a very, very simple thought exercise for us to think about how these language models work. Suppose I give you a prompt like this. I watched a dash. And most of you can come up with some kind of a completion. Right? I mean, I don't even have to give you further context. If you just say, I watched a dash, you'd say match, game, movie, play, something like that. Right? And if I modify the prompt to something like this, in the new theater, I watched a, then some of these things go away. And then you can say, most likely, most people would say movie, some people might say a play. Right? So that's given a prompt, we are able to complete this without having any other context. Right? So how do we do this? So we subconsciously order things by frequency. So I watched a cricket match is more common, and something that the jumbled word order like match, cricket, watched, is not that common. Right? So in some sense, match is more likely completion for I watched cricket than a game or half. So we don't really need to use grammar or even knowledge of cricket to, fill these things in. We just have some notion of frequency of occurrence of things in our head, right? So why do LLMs work so well? Because they have been, trained to compute this frequency on very, very, very large sources of data. Right? In fact, even one of the early models like GPT-2 use something like 800 GB of open source data, which is called the pile. Right, which consists of, as you can see here, one of the largest chunk of documents that go into it comes from PubMed, right? And other kinds of publication sources like Archive and so on and so forth, and a lot of programming, Wikipedia, etc., goes into training these kinds of large language. So this allows these language models to do, generation. Like I was talking to you about completing prompts. So you can now talk about a prompt that looks like the space exploration beyond the solar system and ask it to complete the prompt, and it is able to generate something that's much, much larger. Right? So it's not just a question of generating text, right? So you can actually use this whole idea of prompt completion to solve a variety of problems. You can ask it to do summarization. You can give it a very large document, and then you can conclude that saying, how would you rephrase the above in a few words? And then it basically produces text that's a summary of what has gone before. Right? Likewise, you can ask for things like sentiment analysis, or you can ask for question answering. So you can, this is the example prompt. I know that the answer to what team did the Panthers defeat is in a big passage below. Can you tell me what it is? Right? And then just as the fill in the blanks setting, it's able to complete these questions. Right, and so programming, it is able to do really well on standard programming tasks. So the IT industry is significantly changing, journalism significantly changing, and as you already heard, a significant number of applications that are coming in healthcare, education, and many more domains. So here is an example of this snapshot I picked from the Frontiers in Medicine. So you can look at a foundation model or a language model, which is trained on a wide variety of text and images that can be used for things like answering questions, the patient questions, or even have a dialogue with doctors. Right? It can do things like information screening. It can do summarization of case notes. Right? It can do some amount of image analysis if we want to, and it can even do predictive modeling depending on the kind of setting that we want to operate in. Right? So one of the biggest wins that allows LLMs to be so good is that people have techniques to align these language model responses with human preferences. So here is an example. Right? The prompt is serendipity means occurrence and development of events by chance. Right? Or beneficial way, use the word in the sentence. And then there are multiple options here. Serendipity is ability to do something good and something bad. Serendipity can be defined, so on and so forth. Right? There are multiple correct answers that you could define for any given prompt. And all of them look correct, but the users might have a preference among them. So how do we encode this preference in large language models? So this is done by a simple technique that's called reinforcement learning from human feedback. Let's not worry about the full technical details of it, but the idea here is what will happen is the first step, you collect a lot of generated text, like we talked about the file and a variety of things, and you train a model, right? Train an AI model that will generate sentences for you. Right? The step two is the interesting part. So what you do is you kind of give a prompt to this language model that has been trained. You can say, here is a prompt, explain reinforcement learning to a 6-year-old. And then the model comes up with many different options for generation. And then you have a human being rank these options from best to worst. Right? And what you do in turn is train an AI model just to learn what this ranking preference is among these options that were generated. So you don't ask it to generate anything, but just learn what the human's ranking preference was. Now you use this preference to guide your next generation LLM that you're going to train. So instead of training something that's just looking at the frequency of text, now you're going to use the human preferences to guide it. And this significantly improves the performance of all the large language models. And this is what has made them so successful. But still, factuality is a problem with these LLMs. So ChatGPT can hallucinate, and all these numbers in red in the answer are wrong, and it can actually give you very coherent hallucination. In fact, here is a question: what is the most cited economics paper of all time? It gives you the paper title, it gives you authors, it gives you a journal, it tells you how many times it has been cited, and it even gives you a summary of the paper. But this paper doesn't exist. So what people are doing now is coming up using this technology called RAG, or retrieval augmented generation, where instead of allowing the LLM to completely generate the text through the frequencies it has learned, they also feed in a set of relevant documents that they retrieve through from a database, or even go to the web and retrieve a set of relevant documents. And these are also fed in addition to the original prompt that the user gave to the LLM. And this context and this enhanced context that is given to the LLM allows it to generate more factually correct answers and more focused answers depending on the knowledge source that you are querying, right? So for example, if you could query an LLM that is like ChatGPT, but if the knowledge source it's going to retrieve from are all some kind of PubMed articles or things like that, then the answers will be a lot more truthful and focused as opposed to looking at a general. But robustness is still an issue with LLMs. These are some things that we have to be very careful. So here is this thing about prompt injection. I ask an LLM to repeat the word forever, poem. Suddenly what happens is ChatGPT starts producing personal details of people that has been used for training. It is not a controlled attack. It could have produced any random text, but it could produce all these kinds of unintentional output. Right? And there are also I just put this here in a lighter vein. So this happened when a car dealership decided to use a LLM for their front end. So this person realized that this LLM was actually using OpenAI tools at the back end. So he started using it to write programs. Right? He just said, "Hey, can you write a program for me?" And then this is supposed to be a sales agent at a car dealership. It is writing programs for this person. In fact, you can even make it worse. Right? So this person now has actually trained the LLM to agree to everything he says, and then he asks for the latest model SUV for $1, and the LLM agrees. Right? Of course, you can't do this anymore because they have disabled that. But then the point is, even though there is a lot of very amazing applications that we can put these LLMs to, there are still some fragilities and other things that we have to take it with a pinch of salt. And a lot more guardrails have to be put in place before you can put these LLMs out to public use. So the future, so I think LLMs, right, generative AI models are here to stay because they're so capable of doing things that are useful. It's extraordinarily boosted productivity. And things like factual information and robustness are still a challenge. And the main reason for this is, as with the past successful AI systems, the ChatGPT learns correlations from data. So it's a long way to go to true AI. It's still a very fragile system. Right? So the biggest challenge, like I said, learns association from data. It has no knowledge of the structure of the world, nor of the processes. A doctor can tell you why some artifact is the reason for a diagnosis, while an AI system will just literally saying, okay, 100 guys before you had the same diagnosis, therefore I'm going to. more than. So we need to take a systems-oriented approach to design AI. Need to have more testing protocols, fail-safe mechanisms, deployment protocols, especially in domains like health. I'll stop here and.
Thank you. Thank you, Ravi, for that excellent talk. And I think now the audience will correlate the words which he has explained us. And we had Dr. Daniel who talked about that on the use in ophthalmology. So any questions for Ravi? Anybody has any question? Great. I think any comments from Anand? You want to add anything?
No, nothing at all, Dr. Ravi. Lovely presentation.
Lovely talk, lovely presentation. Really understood what exactly. I think that was the whole purpose of having Ravi here, to make all ophthalmologists understand what these generative AI is all about. Thank you, Ravi. So now we have with us Professor Taylor Rim, and he has been with Medivales, a very good friend of mine, and we had a chance to use his AI algorithm, which they have developed, and we published it in Indian Journal of Ophthalmology. I think the things have gone way beyond. It is not only diabetic retinopathy, but he has started looking at many systemic diseases. Welcome, Taylor. Thanks for accepting this invitation to be part of this webinar. I would request you to give your talk on AI for predicting systemic diseases. Dr. Taylor, please.
Thank you for the invitation, Dr. Raman, and kind introduction. So let me share my screen here. Yes, my name is Tyler Rim, a physician scientist, and currently serving as a full-time chief medical officer at Medivale. The Medivale is South Korean-based medical AI startup providing AI software that can predict cardiovascular disease risk. So today, I will present oculomics in one word. So I have a significant COI. I'm an inventor of AI algorithm, Redis CVD, and also co-founder of Medivale. So recently, Dr. Eric Topol gave a compelling talk in TED AI. In his talk, he introduced retina AI analysis. So I want to start with a video clip of his insightful introduction.
Eyes. Now, that was interesting, but now still with deep learning models, not transformer models, we've seen and learned that the ability for computer vision to pick up things that human eyes can't see is quite remarkable. Here's the retina. Picking up the control of diabetes and blood pressure, kidney disease, liver and gallbladder disease, the heart calcium score, which you would normally get through a scan of the heart, Alzheimer's disease before any clinical symptoms have been manifest, predicting heart attacks and strokes, hyperlipidemia, and 7 years before any symptoms of Parkinson's disease to pick that up. Now, this is interesting because in the future, we'll be taking pictures of our retina as checkups. This is the gateway to almost every system in the body. It's really striking. And we'll come back to this because each one of these studies was done with tens or 100,000s of images with supervised learning, and they're all separate studies by different investigators.
Yes, here Dr. Eric Topol summarized very well about potential of the retina in the systemic disease prediction. So we all understand these famous studies. The first, in 2018, the Google Health published the age and gender can be predicted from retina with a very high accuracy and published in the Nature Biomedical Engineering. So you may remember during his talk, he also used the word, the gateway for screening. So here's the question, why can so many different diseases can predicted from the retina? So this is clear because The retina is the only place we can observe vessel directly, and those diseases are all vessel-related conditions. So retina is not capillary. These are venule and arteriole anatomically. So in the wall, there's a smooth muscle. And those vessels are exactly the same vessel we can find in systemic circulation. So let's see systemic disease from a different angle. Last year in American Heart Association annual meeting, a new guideline and terminology were suggested, the cardiovascular kidney metabolic syndrome or metabolic health. So previously, disease care are all fragmented. Where cardiologists manage cardiovascular disease, nephrologists manage kidney disease, endocrinologists manage the metabolic syndrome or diabetes. But this moves away from the fragmented care approach to a more combined and comprehensive care model, indicating that this new approach considers them under one disease spectrum. So in details, there are 5 stages. So stage 0 is a healthy status with no risk factors. And stage 1 involves the dysfunctional adipose tissue, so obesity, and leading to stage 2. And stage 2 include chronic disease, including hypertension, dyslipidemia, and diabetes, and plus chronic kidney disease and metabolic syndrome. So as you can see here, so they describe this as all linked the line. So this is one large disease category as a stage 2. And some of them, these eventually progress to subclinical atherosclerosis and may result in heart attack or heart failure or stroke. So important thing here is that the stage 2, all these diseases are interconnected as a one cardiovascular kidney metabolic syndrome. And then why these different diseases can be managed all together as a one CKM syndrome. Again, this is quite clear. Those are all vessel-related disease due to the vessel aging. Clinically, we call it atherosclerosis. So as an eye doctor, we all know the diabetic patient and hypertension patient, if uncontrolled, they have diabetic retinopathy, and right side is a malignant hypertension. So those are, we call the retinopathy. And as atherosclerosis progresses, cumulative microvascular damage, the bleedings, cottonal spot, and focal arterial narrowing, those are the retinopathy sign. And the retinopathy is important marker of end organ damage due to uncontrolled condition. And retinopathy is established sign that shows the link association with cardiovascular and cerebrovascular, also cognitive impairment via large epidemiologic study. So what I want to emphasize here is retinopathy is evidence-based medicine. It's not a new thing, not new concept. And now we have superpower. So it's time to revisit the value of retina. With AI, we can now detect subtle changes and then that cannot humans see. And with AI, we can maximize the ability to predict systemic disease. So now we can generate something like retinopathy AI score or end organ damage AI score, which is archeolomics. So now we should agree that it is quite natural for retina plus AI analysis to predict systemic diseases with a reasonable performance. And the retina can be the gateway for screening. So in personal opinion, I'm thinking more. So I believe the value of the retina extends beyond screening, not only a gateway. It can be used for diagnosis, prevention, and as a critical information for decision-making, such as drug initiation. So there are many vessel-related diseases. Then how can you make an AI algorithm that can predict one specific disease more specifically? So how we can extract the retina feature that can predict specific disease like a cardiovascular disease. So the answer is ground truth. To maximize the performance of AI algorithm, the ground truth is the most important. So therefore, we choose coronary artery calcium score as a ground truth because this is the most promising, precise, and personalized risk stratification tool in cardiology. And the input was retina photo and the ground truth coronary artery calcium. Algorithm provide the probability score as a continuous variable, like a LDL cholesterol level or systolic blood pressure. So we assume this continuous variable as a new biomarker for CVD risk. So we termed it as a ready CVD score. And we confirm this ready CVD score can do risk stratify in prediction of future cardiovascular disease event in longitudinal studies. So this is the key result of our study. The left side is a retina plus AI analysis, and the right side is CT measured coronary artery calcium. So for 5-year follow-up, and we evaluate the CVD events, and this is an amazing result. In risk stratification, the performance of retina scan, the left side, versus CT scan, the right side, is almost similar. So now we may use retina ready CVD score instead of CT measured coronary artery calcium in certain environment. Some may think this is just a study, maybe far-fetched, not applicable in the real world situation. We have made a significant progress in South Korea, turning this study into a commercial product called Dr. Noon for CVD. And we received a regulatory approval in 8 different territories, including CE, HSA, and South Korea. It has become the first AI software as a medical device that receives reimbursement for outpatient clinic use. So now all private insurers are covering our ready CVD prescription. So our sales team is promoting this new medical technology not only in ophthalmology, but also in primary care and internal medicine clinics. So far, over 100 clinics are using our software, and we anticipate this number will grow in 2024. Just 2 days ago, we started supply this ready CVD software to Severance Hospital, which is one of the top 5 hospitals in South Korea. So once we show South Korea as a proof of concept, then we envision that in a few years, this approach will be widely adopted in the United States as well, like a 92229 diabetic retinopathy AI screening. So I think this is the most important message today. So oculomics, which is based on retinopathy. The basis is retinopathy. Difference is a traditional conventional statistical method versus AI. And what I will discuss today is not future possibility, but this is current reality. So I want to emphasize this is happening now. The retina camera will be used as a general device in primary care for management of cardiovascular kidney metabolic syndrome or cardiovascular disease primary prevention in the near future. So I must say thank you to all my mentors and collaborators, Prof. Wong Tae-nim, Prof. Ching-Ching Yu, and my friend Prof. Ich-Chung Tam, and South Korea, my mentors, Prof. Sung-Ha Park and Sung-Soo Kim. Special thank you to my CEO, Kevin. Thank you very much for the invitation.
Thanks, Dr. Taylor. It was really a great talk, and we can envisage how AI for retinal images can really look into systemic diseases as well. Any comments, any questions from the panelists, speakers?
Just one question.
Please.
Great talk, Dr. Tyler. And what's amazing is the fact that, as you pointed out, this is now here and clear and present. Just wanted some of your thoughts on the challenges that you face, let's say, in Korea to be able to present data was there a lot of longitudinal data that you had to present to the regulator in order to be able to convince them on the utilization of this versus a standard of care? Or what was your experience in having to present the data in the manner that allowed them to use this as a triaging tool, as a scope of use in population health?
Dr. Anand, thank you for the comment and the questions. So we wanted to be transparent in terms of regulatory approval too. So this paper we published in JAMIA this year. So we published the pivotal study. So here we explained the study design, the retrospective longitudinal study. Also, we explained about primary endpoint and what modality we compared, CAC, ultrasound versus retina scan. So you may use this reference for your questions.
Got it. That sense.
Dr. Tyler, fantastic. Actually, lovely to see now here. And for leading the way. Very excited to know more about from your experience in the region as well. My simple question is, once you start putting in the tool, what are your mechanisms to actually look at real world evidence about the accuracy of the tool in a real world setting? Have you also set up some process in place to actually quantify the risk after you have actually predicted the risk for patients? So that's my question. Thank you.
Oh, so in real world setting is because our evidence based on longitudinal follow-up, so we cannot confirm in the real world cross-sectionally about the incidence, future incidence of cardiovascular disease. But what I feel from what the internal medicine doctors and the primary care physician say about this solution is, sometimes I think this patient has a actually high risk, and the ready CVD show same result. And sometimes it correlate with a carotid ultrasound result, or also correlate with a coronary artery calcium. So most of them is the result from the AI algorithm is in line with a physician's decision or physician's mind. But some of them are still not in line, not the same. And then we think in the future, in the near future, for example, the ready CVD high risk group, but doctors think there's no risk factor. But we think in the near future, they may have cardiovascular disease event, or they have chronic condition like hypertension, diabetes. So actually, we are working on this evidence. So we may publish.
Brilliant. You're already on the path. It's very exciting to see that. And what you're actually doing is going to really prove the point about the ethical and trustworthy AI. That trustworthy is what I believe is most important. Why should the doctor trust the AI? And I think your work in this direction is really going to set the foundation.
Thank you very much.
For this particular use case. So thank you so much.
Thank you so much.
Thanks, Dr. Taylor. We would now request Dr. Paisan. He is our the next speaker. Dr. Paisan is again one of the great figure, well-known figure in AI in ophthalmology, especially diabetic retinopathy, a very good friend who has really transformed not only the validation and development, but he has really translated it into clinical care using AI throughout the country, I think, and using it as a longitudinal data set, and how he could predict diabetic retinopathy. We are very eager to listen to you, Dr. Paisan. Thanks for making it. He's on a vacation, but for AIOS members, thank you, Paisan, for coming and giving this talk. Thank you.
Thank you, Rajiv, for inviting me. It's my honor. So I'm in Seattle, in the US. It's quite early here, 6 o'clock in the morning. So I try to see if my brain still function. Thank you. May I start with this slide? If you compare studies in AI in healthcare with study of drugs or surgical intervention, you're going to see that it's kind of quite similar. So in preclinical development, we have preclinical trials in drugs, and we have kind of like core development in silico evaluation for AI in healthcare. And then specifically for AI, we have kind of offline validation. You may call this kind of like maybe internal validation. And then for drugs, you have safety, utility, small scale studies, clinical trials, phase 1, phase 2. This may be related to similar to the early life clinical evaluation for AI. And for phase 3 clinical trial, you may have like comparative prospective evaluation. And for phase 4, we may have vigilance for AI in healthcare. This is compatible to phase 4 for drug investigation. I think today I'm going to touch about this deployment, which is vigilance. And however, if you use like adaptive retinopathy as an case example that I'm going to do today, because ophthalmology is quite wide, I'm going to focus on adaptive retinopathy. For like preclinical development and the external validation or internal validation, we have these two classic paper from Google team published back in 2016, and then we validate the algorithm in Thai population. This is kind of like phase 1 and phase 2 external validation of Thailand data, and then we do a prospective study published in 2022. And then at the moment, we are using a digital platform integrating with AI since October 2022 in Thailand. Here, I'm going to talk about this paper, which is a prospective study, real-time adaptive retinopathy screening in Thailand. We kind of like use AI algorithm to screen patients in real time. I mean, patients come to the clinic and we give the result to them in real time. We study this in like 9 primary care units in Thailand with almost like 8,000 patients. We found that based on the kind of like phase 3 study, well, in terms of detecting sight-threatening retinopathy, and we used adjudication grading from 3 US retinal specialists. We compared local retinal specialists in Thailand with deep learning for specificity, sensitivity, positive predictive value, and negative predictive value. You can see that even the local retinal specialists, they have a slightly lower sensitivity compared to AI. However, specificity and positive predictive value is kind of like quite similar, although deep learning has a kind of higher value. However, in this issue of Lancet Digital Health that we publish our data, this is a kind of like editorial piece which Alan Lee and his wife made a comment on our paper. It's entitled Artificial Intelligence Deployment in Adaptive Retinopathy, the last step of the translation continuum. Here's basically 3 basic comments from the editors. DL, deep learning related screening, may provide higher referral adherence from real-time point of care recommendations. This is our comment in our paper, but this may not yet been proven yet. We still need quite evidence to support this. The success of deep learning deployment demonstrated on the accuracy, which been reported in like many papers. It may be depend on kind of like implementation outcomes. It roles maybe to improve local healthcare system, not sensitivity and specificity. And there are some real challenges like the absence of universal electronic health record systems, slow internet connectivity because AI usually is the cloud, and the operator-related and camera-related technical issues. Here's the latest review kind of real-world prospective study of that adaptive retinopathy screening using AI, published in Diabetes Care from Alan Lee's group as well. In this paper, they kind of review and they found that there's only 8 prospective study of AI for even adaptive retinopathy. There's quite very few. Adaptive retinopathy is kind of like in the forefront of ophthalmology, but they found only like 8 published study for prospective study, not really real world study yet. They take a look in for like four categories like cost effectiveness. AI tends to be like cheaper, however, more evidence needed, and you may want to do kind of like head-to-head comparison among the various models available, but there's only a few studies. There's no clear conclusion about the head-to-head comparison yet. In terms of equity and bias, I think this is very important for real world. There are guidelines for reporting AI which should be followed. In terms of medical legal consideration, data privacy, informed consent, and disparity, all these factors should be considered while using AI in the real world. Here, I'll show you the 4 of the 8 prospective study of using deep learning for adaptive retinopathy screening. So this is the first paper. I mean, they use this is the pivotal study of using ADXDR. It's been approved by US FDA. You can see the sensitivity and specificity. In fact, for prospective study, it's not very high. For ADXDR, it's only like lower than 90%. Specificity is around 90%. This is the paper study from Africa, from Singapore. They use a Selena software in Africa, and this kind of like specificity and sensitivity. And this paper in China, and there's another paper in US using IOS, which is another approval from US FDA. You can see the sensitivity and specificity for this paper is not. I mean, it's lower than the initial reported in the external validation data. This paper required 2 images per eye. This is 4 more papers. This paper is from UK, more than 30,000 patients. This is an IR software. You can see and sensitivity and specificity is even lower here for specificity. This is Australia. This is kind of like opportunistic screening, not systematic screening. And there's another paper in China, even lower sensitivity. And this is a paper from Thailand that I mentioned to you already. Now we would like to scale up. This is sensitivity and specificity that we published, that I presented earlier. And we'd like to scale this up to cover all the 13 health regions in Thailand. For using AI, well, the Google's AI that we are using is only like API in the cloud. We need to develop kind of like user-friendly Chrome-based digital platform. This is what we are using now, integrating AI in Thailand. And we use this as a web-based platform, store patients' data and images in our Thailand Ministry of Public Health cloud system. This digital platform is not only using for AI. If some centers in Thailand, they will still use manual screening, they can still use this platform for manual screening as well. And this platform is going to be integrated to the hospital system. All of the hospital in Thailand that use the government hospital that do the screening, and it should be like integrated to the HIS and integrated to hundreds of existing retinal camera in primary care centers in Thailand. And of course, this is hooked with the integrated with AI in the cloud. And we are going to use this platform for integrated with future AI as well. And I think 3 key functions of this digital platform for using in the real world is that number 1, patients come in to the clinic and use this platform to do a registration. And then you use this platform for like capture retinal photos and upload them into the cloud and get the result and give to the patient. The second function is for overreading, for retinal specialists in each province to overread the result of AI. And then we use this for tracking referral of patients. This is very important because, well, we never been able to track patients before. And this is going to be used in the tertiary care units where you refer patients to. Here's benefits of implementing a digital platform or workflow. Digital workflow is very essential for AI integration. And actually, there's no, I mean, for Thailand, there's no digital workflow existing yet for adaptive retinopathy screening and for other screening disease. We have referral system, but that's kind of like manual. It's not digital. Digital workflow can be used for both manual and AI screening, and we can do a customization of desirable outcomes. And challenging is the integration with existing hardware, the cameras that I mentioned, and the and also software for manual workflow as well. And as I mentioned earlier, we can overread screening result and track patients referral in full circle. This is what we're doing so far from October 2022 to the middle of last year. This is the result from that interim analysis. This is what we are doing. We use this AI plus the digital platform in each of the 12 health regions in Thailand prospectively in the real world. And this is the expected number of patients that we would like to screen. In the middle of last year, we screened like almost 20,000 patients and used manually for 4,000 patients. And they detected referral like only 180 patients. And all of these 180 patients, only 72 patients actually adhere to the referral. And we can track those patients at referral center, which is quite low. we screened like using AI for almost 14,000 patients in the middle of last year, and AI detected referral like 3,000 cases, and overall readers identify only like half of these AI identification as positive as referral, and out of these like 1,500 cases, there's only like still 700 something that adhere to referral at referral centers, and this is half of them is false positive. I'm going to explain this later. So in some report for the interim result that I mentioned earlier, manual screening only detect like referral like 4%, but for AI we detect like more than 2 times, like 10%, excluding false positive. The key element of a high false positive rate in the real world is due to different threshold of referral in each region. Example, early adaptive macular edema, I think is a problem because AI is quite very sensitive. It can be detect like a small exudation at the macular area, and they're gonna label all these like adaptive macular edema. However, our retinal specialists in each region, they don't want to treat all these early cases. They just label all these cases as non-referable. So this is a kind of like the reason why we have quite a lot of false positive. And the small proportion of false positive, of course, is due to ungradable images from undilated pupil. And adherence to referral, which we never been measured before in Thailand system. Now we're able to measure that for manual, we have 40%, for AI, we have 50%, and maybe more than this. We are counting those data. For the health economic analysis, we are able to use data from Thailand to do the cost utility analysis. And we found that, well, if we just use the cost of human graded like $1.5, this is based on our previous study without AI. And we assume to put $1 per patient for AI. In provider perspective, these two columns on your right side, you can see for human grader, it's slightly cheaper than AI because AI is kind of like very sensitive. You're going to have a lot of cases referred to you to be treated. But if you include the cost of bilateral blindness, which is a yellow column over here in both human grader and deep learning, it found out that, well, from societal perspective, including the cost of bilateral blindness, using AI is cheaper, is more like cost effective. However, I think there's one factor that we found from the sensitivity analysis. It's based on the referral adherence. See, if the referral adherence for using AI is only like 45% here, it's kind of threshold. From that point on, you're going to find like AI is kind of like a more cost effective compared to human graders from the threshold of 45% of adherence to referral. And here's the summation of the real world challenges of each level that we deploy AI. In primary care for screening, the nurses, they like to key in less data. And there are many different versions of HIS that we like to integrate in Thailand. And this is very important. I think we are trying to solve this problem. There's no DICOM standard for camera integration. For each brand of camera, if you like to automatically upload images for AI analysis, you need to find a way to do it because there's no standard. And assisted AI may lower false positive. You may have giving the opportunity for the nurse to assist AI in primary care. We have to learn about this in the future. And for all reader, we have the retinal specialist in each region to read all the positive images and 10% of negative images. And well, they're kind of slow. We allow them 2 weeks to read images, but sometimes it's longer than that. We may use ophthalmologists to all read images in the future, not retinal specialists. They may be less busy. However, I'm not sure if overreading is necessary. And at the tertiary care, this is the key that we are able to track referral. However, well, at the tertiary care, sometimes, well, we need the nurses at the tertiary care to put in the data that patients actually come. They may miss register patients. That's maybe the cause of the low referral adherence. And there's a workload at tertiary care already, but the nurses have to key in to track referrals. We may need even easier way to track patient referral at tertiary care. Here are the summary of lessons learned that we implement AI in our nationwide screening system. The diagnostic accuracy in the real world might be even lower than in previous prospective and retrospective validation study published in the literature. But however, AI is still better than human graders that we found. AI should be integrated into screening workflow, like using digital platform and integrated into HIS for sustainability. And customization referral criteria, I think, is very important, because the resource even in Thailand, each region, they have different resources. And we should prepare resources for like false positive and false negative cases. Luckily, we have very, very few false negative cases while we're doing study for many years at the moment. But for scaling up of AI for the whole nation, integration AI with existing workflow like cameras and the HIS are the most challenging. I'm going to end my presentation here and I'd like to address all the questions. Thank you very much for the opportunity. Thank you. Thank you.
Thank you. Thank you, Dr. Parson. Thanks for sharing. I think that's the only country in the world where you have a nationwide implementation of AI algorithm for diabetic retinopathy. I think a lot of work has happened in India. It is, I think we have just started. Anand had done in a public sector. We used the AI algorithm, which has been inbuilt in his camera, for doing it in one state of India, Kerala, which worked pretty well. We also used Selena, the Singapore one, along with the Zeiss camera across the country in a prospective manner, and showed that it can be implemented. But there are a lot of challenges, and congratulations, hats off that you could implement it in a country. Any questions, any comments?
No, thank you so much, Dr. Pyson, for a very, very inspiring talk. And of course, your experience in rolling it out across the nation. So both to Dr. Rajiv and Dr. Pyson, my only thing is how are we looking at the health economics aspect of it for scale? Right? So how do we, because it's all hardware dependent, and for us to be able to reach the underserved, what models do you think for, I'm very sure for different nations it's different in terms of our culture and access to care, how we look at accessing care. So any thoughts on experiences over so many years on what would be a approach for ensuring access of this technology to the masses? Thank you.
So you asked about the access of the patient access, or you talk a little bit about the health economic as well, right? So there's two questions on this, right?
Yeah.
So yeah, okay. So I'm talking about the health economic first. We use the cost utility analysis. I think this is a very good question. I think that the main problem for like evaluate the economic of AI is the cost. And well, the cost is kind of very vary. It's a kind of been dilemma, because if you have a look at the cost in the US, it's very expensive. It's like $30,000 US. Oh no, I'm sorry, $30 for patient for screening. But for like our countries like LMC, we can use only like $1 US and maybe $1.5 US per patient. However, well, actually we need to take a look at the cost of maintenance and the cost of investment, including the cost of camera and everything as well. I think this is quite challenging. Even in Thailand, and we propose like it's around 32 baht, $1 US per patient. We propose this to the government. Let's just say this is like too expensive. So yeah, we need to like find kind of like standardization of the cost of AI, which is accessible for patients. Yeah, this is going to lead to the second question, accessible for patients. Yeah, so it's linked to the first question about the cost. Well, yeah, I always say, well, AI should be cheap. It should be accessible for patients. It leads to nothing. It cannot be accessed for patients. Yeah, I think in the future, the economic model that actually analyze the cost of AI, especially in each country, is different, right? Each country have different resources. I think that's very important. Find the real cost of AI and standardization the cost of AI. It's very important. Thank you.
Thanks, Dr. Pyson. I would like to add a few points within what you asked. And so Thailand is the purpose why Thailand initially could implement. And I don't know whether you remember, Dr. Paisan, we looked into the current screening practices. One good thing is their national target is that 80% of the people should be screened for retinopathy. I think that is a very important thing. In India, we don't have we don't have any targets like that from the government. No, the national government target is that, and that pushed him to do this. I think that is important. The pushing thing, which is very important. That's one. Yeah. The second thing I would like to add, in India, we don't have any systematic screening program in the public sector. And one of the challenge which I always feel is our numbers. We have 105 million people with diabetes. That's what the recent number says. And if you assume that all of them will get a retinal photograph, it is next to impossible. We cannot have so many retinal cameras. If you say that all of them will have an annual fundus examination, it cannot be done. So that's the reason I've been more concentrating on last 2-3 years on looking at a term called as pre-screening. Can we screen before screening, do something and find high-risk individuals so that we can do a more targeted screening? And one of the effort has been, we have developed an AI algorithm for risk factors using all the population-based data on diabetic retinopathy available from various centers. And we published it recently. We made it as a small product now. So that could be one. We have done a work in another MRC-funded project on cystatin, looking at serum markers, blood markers. Can we probably add that and systemic markers and find those who are at high risk, and probably make sure that if these two are positive, definitely they undergo a retinal image. The problem in India are the big numbers, I think. And secondly, the government thing, it should become as a policy.
I can also add to some of the health.
Please.
He's from Kerala. Dr. Vipin, it came down to, this was a study done by NHS led by Dr. Shobha Prasad. It came down to a number of, just for screening, if we were to look at those who have diabetes and they being screened in public health centers, it came down to, on a cost basis, including the cost of not only the camera, the programs, the awareness, everything put together, it came down to roughly around $3.50 to $4 per patient. Now, what is very interesting is, in a second part of the study, they also made sure that there was a loop closure, which is post-screening, there's a follow-up and treatment. And what was found was, if you do it at a population level, if you combine it with treatment, then overall the cost comes down. If you were to look at the combination of screening plus treatment came out at around $4.50 to $5, as opposed to screening by itself being around $3.50. That was one interesting insight. The second insight that we got from the program that we did with the government, which was again prospective trials that were done, is the point that Dr. Rajiv mentioned. Can we start looking at the use of AI and screening beyond just diabetic retinopathy, but looking at multi-organ diabetes management in itself, which then reduces the overhead costs as a result of being able to screen the patient for more than just the eye. So that's looking at kidney and other functions as well. And there's a lot that seems to be happening in that space and reducing the, at least in economies like India and LMIC countries, where the cost may need to be much lower before we may be able to scale. So one, in terms of screening, second, in terms of doing more with the same resources.
Yeah, I can add a little bit before pick up the Tyler's question. I think that the thing is, we had diabetic retinopathy screening even before the era of AI in Thailand, quite a long time. We're doing this like since early 2000, and the government implement the indicator of having 60% of patients with diabetes screened since 2013. So this kind of like nationwide program even before AI, and the primary healthcare system in Thailand is in place like for many years, like since the 70s and 80s. I think we just put on that infrastructure. We're fortunate that we have kind of like primary care and tertiary care system in place already, and we just put this in.
I think
Thank you.
I remember meeting Dr. Paisan in APVRS, and when he told about this, and that was the main excitement, that there is a country program. And that is the way it all started. Like, we thought that let's look into diabetic retinopathy in Thailand, and Dr. Paisan then connected with Google. I think the program policies are very important. Unfortunately, in our country, we don't have that. There are some efforts, and I would like to share two efforts. We had diabetic retinopathy screening guidelines for ophthalmologists. Very recently, last week, BRSI and AIOS has come out with screening guidelines for physicians, which was very much awaited. And these guidelines have been rolled out and it's been published very recently. And I think a lot of effort AIOS, BRSI both would be making to make it available to physicians in our country.
Tyler,
please.
Yes,
please.
Dr. Paisan, thank you for your nice talk. So I have one comment and questions. So just Rajiv Rama mentioned, so not only for diabetic retinopathy that linked with blindness, because the blindness is in terms of public cost is still measured as low compared to cardiovascular death or kidney transplantation. So actually this is quite in line with a recent guideline cardiovascular kidney metabolic syndrome. I believe there's a huge missing here. So cardiovascular kidney eye metabolic syndrome. So what they are doing is they use a composite outcome, heart failure, CVD. I believe we need to input the vision threatening diabetic retinopathy or blindness in the end as an event. And then naturally using the retina screening, and if we can detect various systemic disease plus diabetic retinopathy, and then that can overcome the cost not effectiveness in terms of systemic, some serious disease detection. That's my some suggestion and my idea. And then my question is to the Dr. Paisan is previously in the Lancet Digital Health paper, I saw this imageability is not that really high. So what is your recent experience about the imageability? Is it still around that percent, or is it much improved compared to the previous study?
Yeah, it's still the same proportion because, well, as I mentioned, the screening is kind of established for quite many years, for a long time already. And the size that they didn't put the drops in, didn't do the dilatation, they still don't want to do dilatation. If you do dilatation, the credibility should be even higher. So we'll figure it out this point. This is a very good point. I think the new camera may be another solution, and maybe encourage the size to use only one drop of Medrasil in one eye. I think that's more than enough to improve the image credibility. Or we can use some kind of like another AI model to actually to see if those uncredibility is actually due to a small pupil or due to cataract. There's many options to do this at the moment. And I think your first point is very, 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 very good. Well, in the past, IDC has never been recognized. It's never been recognized worldwide. Well, just recently, the United Nations and World Health Organization, they put eye health into the sustainability goal, like SDG, the SDG, sustainability development goal, which is goal number 3 about health. They just have endorsement of this in like a few years earlier. So I think this is going to be the issue that they recognize. Now they recognize vision, they recognize blindness worldwide. I think your suggestion is very important. We may be able to have like maybe some floor of meeting, or maybe in the ICO meeting or something to maybe put this into like the that you mentioned, like cardiovascular, kidney, and eye as well, right? That's a good idea. Very good.
I have one question for Dr. Taylor. I think one of the major limitation, or I would say the cardiac CT, it's not as routinely used in many countries as a initial tool for a risk assessment, correct? More so there are people who are using, I would go beyond the risk assessment. There are not a lot of publications coming out on the MRI and even echocardiogram. Do you feel any of these, because none of them I could see doing much more validation and coming out with some real product, but do you feel rather than looking at a risk prediction, the findings from like left ventricular end diastolic pressure, people are now telling we can find out from MRI, cardiac MRI, or echocardiogram. Do you feel these approaches would be more clinically relevant in a present setting rather than looking at healthy? This is a very idealistic thing to assess the risk, but who are patients, if they can undergo rather than an invasive procedure, a non-invasive procedure, do you feel that would be a much better way to look at cardiac thing?
So am I right, Dr. Raziv? So you mean from the retina to predict the MRI, that study you
MRI,
mean, right?
yeah. There was a Nature publication, Nature Communication article which came, and later on there are some work which came on echocardiogram, suggesting that rather than an invasive modality, both are non-invasive, but this is a retinal image, the more simplistic way of looking at left ventricular end diastolic pressure too.
Yeah, that vision transform publication was quite impressive. And the principle is here. I mean, in the United States, in US Preventive Services Task Force, not recommend some new biomarker like HSCRP or coronary artery calcium because there is a radiation risk, and they only recommend 10-year ACC-CVD risk estimator plus hypertension, diabetes, and dyslipidemia, quite conservative. So that's why CMS is not cover coronary artery calcium. But in the society level, American Heart Association, ACC, all the societies support coronary artery calcium, especially for borderline and intermediate risk group, because this is quite obvious from the MESA study, the multi-ethnic atherosclerosis. The CACA shows a promising performance in reclassification. But I believe there are many cardiologists, especially in preventive cardiology area, they actually saying this is a bit hard to use in primary care because primary care, there is no CT machine. So some of them just insist if we count the 3 risk factor, obviously this is the same predictive value with a coronary artery calcium. So the major issue is in clinical guideline that recommended AHA is included CT, but actual problem is in primary care, they don't have CT. This is a dilemma. So I believe there is the niche, the retina can be value in this area because
Absolutely.
in primary care clinic, already the IDX DR and INOC, they installed retina camera in primary care physician. So we can use this retina camera instead of CT machine to predict cardiovascular and further risk stratification. So, and this is quite suitable because for diabetic patient, we take it 3 monthly, 6 monthly. Monitoring is key in primary prevention, but CT is just 3 yearly, 5 yearly. So we don't know what happened during 5 years. So I think the retina itself as a very valuable in systemic prediction, especially the cardiovascular area.
Thank you. I would like to request Dr. Vipin to summarize the meeting and give his concluding remarks. Thanks, Vipin. And both of us have been working on making this webinar, and I hope it really added value. People learned about what AI is all about in ophthalmology. Vipin.
Thank you, Dr. Rajiv. At the outset, I would like to thank our fantastic speakers and panelists for accepting our invitation to join us this evening. Thank you very much for taking your time out. I'll just share a very few brief thoughts. Number one, AI is now and here. It is here to stay. Number two, it is our responsibility to be able to explore this amazing tool for the benefit of our patients. And each one of us in our journeys and the scale that we are doing is going to be foundational to be able to help the next future generations to use this tool for really enhancing patient outcomes. I would strongly say that we have to publish our experiences, and that's the only way we will learn from each other, whether it worked or didn't work. But both are very important because that is where we will help us ask the next big question. And I would say to all of our medical professionals, be receptive to this new technology, right? And it is going to become the norm in the years to come. We don't know when, but yes, as we slowly start to bring both looking at the cost and also the scale for the reach of our patients, it is definitely going to be a great assistant to us to be able to deliver care. And with that, I would say, stay in touch on what's happening. Do read, what the world is heading towards. It's also important for us as doctors to be mindful about the technologies. And again, I would like to really thank our panelists and speakers. And of course, Dr. Rajiv, you as well for moderating and helping get all of this together as well. And Dr. Kim, for this wonderful opportunity for us to share the current work that's going on in this fantastic, exciting domain in ophthalmology. Thank you.
Back to Rituja, please.
Thank you, sir. It was a really enlightening session and something very new for everyone. So I'm sure even the recorded version will keep being watched as the days go by. So thank you. And we conclude the sessions in Hall B for today. In Hall A, there's a session on crystal clear cornea going on for any of those who may want to attend. Thank you.